Hello, this is Dr. Mode, and this video is going to be about the colligative properties worksheet. Question number 1. What is the freezing point of a solution that consists of 5.7 grams of sugar dissolved in 200 grams of water? So what we need is the freezing point depression formula, and here it is, where M is the molality and I is the number of ions or particles that would dissolve. So because this is sugar, it involves carbon, hydrogen, and oxygen, which are all nonmetals, so it's a covalent compound. Covalent compounds will dissolve and just have one ion in solution. So the I that we would use for this formula is going to be just 1. So we just need to calculate the molality. So we need the number of moles of sugar, and we need the molar mass to do that. So we're going to take the 5.7 grams of sugar divided by 360 grams per mole, and that'll give us the number of moles of sugar. Now we just need to calculate the molality by taking that number of moles divided by the number of kilograms of solvent, which is 0.2 kilograms. We move the decimal place over 3 times on the number of grams, 3 places. Now we have the molality. Now all we have to do is plug into the formula, and we get the answer is negative 0.15 degrees Celsius. Question number 2 says, what is the freezing point of a solution made by dissolving 50 grams of sodium chloride in 500 milliliters of water? So again, we need the freezing point depression formula. And now we have sodium chloride. Sodium chloride is an ionic compound. It's going to dissolve into 2 separate ions, 1 sodium and 1 chloride. So I in this formula is going to be 2. So now we just need the molality. So we got to start with the 50 grams of sodium chloride. The 50 grams needs to be converted to moles. Here's the molar mass. So we'll divide by the molar mass to figure out the number of moles of sodium chloride. Now we'll take that number of moles divided by the number of kilograms of water, 0.5 kilograms, to figure out what the molality of the solution is. Now we can plug this into our freezing point depression formula, and we can find that the new freezing point is negative 6.4 degrees Celsius. Question number 3. What is the boiling point of a solution made by dissolving 125 grams of copper 2 chloride in 800 grams of water? So now we need the formula for boiling point elevation. As you can see, the constant has changed to 0.51. Because we're using copper 2 chloride is going to have 1 copper atom, but it's going to have 2 chloride atoms. So the I in this formula is going to be 3. So that just leaves the molality, the little m. So the molar mass of copper 2 chloride is 134.45 grams per mole. So what we can do is we can convert that to moles, and then we can take that number of moles divided by the number of kilograms of water. So we'll take the 800 grams, move the decimal place over 3 spots to figure out 0.8 kilograms of water. That's what we'll divide by to find 1.16 molal. Now we can plug into the formula, and as you can see, we've got the molality plugged in there and the 3 for the number of ions, and this tells us that the new boiling point is 1.8 degrees Celsius above where it was before. Remember, this is delta T. So what we have to do is we have to take and add the boiling point to it, 100 degrees Celsius. So we'll take 1.8 plus 100 to figure out that the new boiling point is 101.8 degrees Celsius. Question number 4. What is the molality of a sodium chloride solution if its freezing point is minus 6.8 degrees Celsius? Well, if we're dealing with freezing point, we've got to use the freezing point depression formula. But as you can see, we need to solve this for little m, for the molality. So here it is, solve for the molality. So we need to be able to plug in delta T, and if the new freezing point is negative 6.8 degrees Celsius, that's what we'll plug in for delta T. And I comes from the fact that we're using sodium chloride, NaCl, which is one sodium atom and one chloride atom, so 1 plus 1 is 2. I is going to be 2 in this formula. So we plug those in, and we find that the new molality is 1.8 molal.